So in order to be able to find the general term of a geometric sequence, just like we had an equation for arithmetic sequences, we do want to have an equation for geometric sequences, and here it is. Now, the difference is that instead of adding, like we did with our arithmetic sequence, and again, if you don't remember, it's Tn equals T1 plus n minus 1 times d. So adding, now we are multiplying, and we're still doing that n minus 1 piece because, again, we don't actually have to multiply by a value in order to get term 1. Term 1 just needs to be itself. Okay, so T1 is your first term, R is your common ratio, that number you're multiplying by. Tn is the nth term, and specifically it's going to be your value. And while n is the number of terms that you're looking at. So Tn would give you your nth position. It's always going to be positive, and it's going to be a whole number. So example 3, we get to play around with this a little bit. So we're told a finite geometric sequence. Okay, finite meaning that it does end. Term 1 is 7. Term 5 is 567. Determine term 2 and term 6. Well, the first thing that we need to do, just like we need to find our common difference, is we're going to need to solve for our common ratio. So I'm going to use our equation. This is how I'm going to think about it. I'm going to look at it and I'm going to go, okay, well, this is 567 equals 7 times r to the power of n, but n is 5, right? Because remember that this is term 5 minus 1. So we're going to divide by 7 in order to appease my order of operations. I'm left with r to the power of 4 is going to be, and that's 81. Well, from here, I just need to take the 4th root. Now, if you don't know how to do this on your calculator, please either Google it, search the type of calculator you have, and then type in like nth root, or you can ask in class, and I'm more than happy to help you. Okay, because every calculator is a little bit different. So we want to be able to take the 4th root so that they cancel out, and I'm left with just my r. Now, this particular one, it's a nice, perfect 4th, and my answer will be 3. So still dealing with r equals 3. We're just starting at a different first term. We're asked to figure out term 2 and term 6, though. Well, term 2 is right after term 1. So times 3 gets me term 2, or 21. Term 6 is directly after term 5, so I'm also going to multiply by 3 here, and I'm going to get 1,701. So that would be my final answer. But again, I could only figure that out if I solved for r. Now, using the same sequence, so I still know r is 3. I still know term 1 is 7. Now they're telling me the last term, term n, is 45,927. How many terms? Well, how many terms is specifically referring to n. What is n? Which term number is this? But we have room to solve for that in our equation. So we start by just plugging in. So 45,927 equals 7 times 3 to the power of n minus 1. Again, the first thing we're going to do is divide by 7. Get that 7 away from our variable. From here, we want to be able to rewrite this number as if it's a power of 3. So we're going to divide, how many times does 3 go into here? We're going to test divide by 3, divide by 3, divide by 3, until we get all the way to 1. And I'm going to do this on my calculator because I'm absolutely not going to expect you to do this in your head. Okay, and I get all the way to 1. I've divided by 3 8 times. So that means that it's actually 3 to the power of 8. I have to go all the way to 1. Not to 3. Okay? So 3 to the power of 8 equals 3 to the n minus 1. Well, my exponents should match, which means that 8 needs to be the same as n minus 1, and therefore n is 9. So this is my 9th term. And there will be 9 terms in my sequence.